Well, this video will be helpful if you're working on divisibility induction. I'm taking one of the IB exam question, Math HL exam question to explore this concept and what are the key steps involved in proving. So when I take the divisibility induction, so for example, if I have to prove that 2 to the power 3n, 2n minus 3n negative 1 is divisible by 9. What is the step that we need to show first? So we take n as 1, begin as the usual, we start with n as 1. Now when it is divisible, so what happens is if I take 2 to the power 2 minus 3 times 1 minus 1 is going to be 0, and obviously this is an integer multiple of 9. So we always try, whenever there is a divisibility question, we always try to take that the fact that if it is divisible, the number that you get is multiple of the divider. Okay, so for example, if I'm taking 2 to the power 2n minus 3n minus 1, if it is divisible by, let's say, 9, so this must be an integer multiple of 9. Okay, so I generalize in general, if I take this as a p, which is an integer, this divisibility statement can be modified. Now what I do is, if I take n as 1, this is, you can clearly see that this is a multiple of 9, because you can say 0 is 9 times 0. Okay, now you take n as 2 also if you wanted to prove, if you wanted to verify. So when I take n as 2, what we get is 2 times 2 to the power 2 times 2 here, minus 3 times 2 minus 1, which is going to be 9. If you do the calculation, 9 times 1, which is integer multiple of 9, where here integer is 1. Now we generalize it for n equals to 1, n equals to 2, and now we have to prove for n equals to k. Okay, so now let's say we take n as k. Now let us assume that this is true for n equals to k. Okay, so it becomes 2 to the power 2k minus 3k negative 1 is an integer multiple of 9. I can take a different integer if you want, 9 times z. Now if this fact is holding true, what we can do is we can generalize, we can prove this. In fact, this is called as the final step. Inductive step is n equals to k plus 1. So it becomes 2 to the power 2k plus 1. If I replace k with minus 3k plus 1, negative 1, this should be also an integer multiple of c. Okay, so I can take, let's say, 9, maybe t or something. Okay, this is what we are supposed to prove by making the assumption and using the assumption that we did out here. So how do we do this? So let's take the step out here. So it's 2 times 2k plus 2 minus 3k minus 3 negative 1. I just took LHS from here. So when I do this, what exactly I get is 2 to the power 2k. I can split this up, times 2 square minus 3k minus 4. So it becomes 4 times 2 to the power 2k minus 3k minus 4. Now I have to use this particular step from here. How can I use this? Okay, so what I do is basically I make, if I can replace this 2 to the power 2k from here, I can get the induction. So 2 to the power 2k, I could do this as 9z plus 1 plus 3k. Okay, so I'm gonna put this out here. So let's say if I'm putting out here, what do we get? So this becomes 4 times 9z plus 3k plus 1 and minus 3k minus 4 as it is. And so what becomes is 36 z plus 3 4s are 12k plus 4 minus 3k minus 4. So if I try to understand, this is 36z plus 9k plus 0. Now if I take 9 common from here, it becomes 4z plus k. Now because we know that k is an integer as well as z is an integer, this has to be an integer multiple. This has to be integer. Hence we kind of proved it for n equals to k. Hope you've done trying this question. Now, what exactly is the marking for this question is? So first thing, what we understand out here is that we take n equals to 1. That's the part number 1 when we begin the induction. Then after this, we verify this because you can clearly see this 14 is multiple of 7. Second step we take is the making the assumption step. So you took this as m as an integer, so you are trying to prove that this is an integer multiple of 7. And the final step which you have to prove is taking n equals to k plus 1. So when I take n equals to k plus 1, my left hand side becomes 12 to the power k plus 1 plus 5 times 2 times 5 to the power k. Now out here again we make the subject from here 12 to the power k. 12 to the power k can be written as 7m minus 2 times 5 to the power k minus 1. So this is the main step which we are using the n equals to k to prove for n equals to k plus 1. So I'm going to put this out here, and you can clearly see that this comes, if you simplify and understand, this comes 7 can be taken out and this is an integer, hence it proves the multiple of 7, that this is the multiple of 7. So do not forget to write the final step because that matters a lot. That counts here for a point. You can clearly see that this is really important, and you need to always support in your final answer. Okay, so hope this video helped you understand the concept of divisibility. Watch the next video, which is on concept of complex numbers in induction. Thank you.